Hello and welcome to today's algebra lesson. Today we will be talking about plotting points. This is something that's probably familiar to many of you. We're going to plot points in something called the rectangular coordinate system. And the rectangular coordinate system very simply is this XY coordinate plane. The x-axis, the y-axis, you've probably plotted points in this before, so I don't want you to be nervous about this, but pay attention to the details because you may have forgotten some. Okay, so the next thing we're going to look at is the naming of where we plot these points. I just told you we have an x-axis, we have a y-axis. Now we also the x-axis and the y-axis split. Think of this piece of paper as your coordinate plane. You're going to split it into four parts. These arrows mean it goes all the way up and down. Over here to the top right, that's probably where you're most used to plotting points because everything x and y, everything's positive there. It's called the first quadrant. That's where you learn to plot the first time, is things in the first quadrant. You have all positive numbers. Then if you move clockwise over to the left, like this. Oops, sorry, every time I press the wrong button, I'm still getting used to this pen thing. Like this, you are now in the second quadrant. Over here, your x values are on the left side of this horizontal axis and they're negative, and the y values are positive. We'll explain more of that later. Then you continue to move counterclockwise to the next quadrant, the third quadrant, and then you continue over to the fourth quadrant. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. That becomes important later in math, but we just want you to know how to name them and how to figure out which quadrant a point is in for right now. So the easiest way to do that is to plot the point and then look. Now the other places the points could be are actually on the axis. You could actually have a point that's right here, right on this axis, or right here. This point here would be on the y-axis. This point here would be on the x-axis. So what do we mean by point? Each point corresponds to what we call an ordered pair. An ordered pair means the order matters. So it's always x, then y. I'm trying to play with the pens here, sorry. We'll fix that. So the first number in each pair is called the x-coordinate. The second number is called the y-coordinate, and it's always in that order. The number before the comma tells you which way to go, left or right. The number after the comma tells you how far to go up and down. Horizontal distance is with the x-coordinate, the first one. If you have a hard time remembering which way the word horizontal goes, it means the same as when you look at the ocean and where the ocean and the sky meet. If you drew a line, that line will go side to side. That's horizontal, and we call that the horizon. Vertical is up and down. Okay, so in plotting points, we move across first, either left or right. So in this one here, the 3 is first. That means I'm going to start at the origin. The origin is this point in the middle here, where the x and y axis cross. And I'm going to go 1, 2, 3 to the right. And then I see the next value after the comma is a 5. That tells me how far up or down to go. So I go 3 to the right and I go up 5. And I would plot the point there. That would be the point 3, 5. For 4, negative 3, I look at this and I go 1, 2, 3, 4. And I go down 3. Oh, sorry, I went the wrong way. 4 is positive, so I start at the origin and I go 4 to the right. And I go down 3 instead because negative implies down. So for the first coordinate, the x-coordinate, if it's positive, you move to the right. If it's negative, you move to the left. For the second coordinate, if it's positive, you move up. If it's negative, you move down. So this point, negative 2, negative 7. 1, 2 to the left because that was negative. I start on the x-axis, so I'm always moving side to side first. And then I go down 7 because it's a negative 7. So that would be negative 2, negative 7. And then this last one feels like a trick question. 0, 0. Right there. You don't move left. You move left none, and you move up and down none. Left and right none, up and down none, so you are right at the origin. Now, we would say this point up here, the 3, 5, that's in quadrant 1. We have no points in quadrant 2. The point negative 2, negative 7 is in quadrant 3, and the point 4, negative 3 is in quadrant 4. And we would say the 0, 0 is at the origin, or it's on both the x and y axis. If I had another point that was just on the axis, I would say that's on the y-axis. So you can either be in a quadrant or on an axis if you're a point. Okay, so here are some points plotted. Look at the negative 2, 4. You went to the left 2 and then up to the 4. 4, negative 2. You start at the origin again. You go 4 and then down 2. And there's 4, negative 2. Negative 3, 0. This one's a little different. You go 1, 2, 3 to the left, and you don't move up or down at all. Oops, sorry about that. I'm still getting used to this software. And you don't move up and down at all. So that one's actually what we would say is on the axis. It's on the x-axis or on the horizontal axis. You can just call it the x-axis for me. That's okay. In D, the x-coordinate is 0, so I don't move left or right at all. I stay right at the origin, but then I go down 3. So you see this point here is on the y-axis. 0, negative 3, and we would call that a y-intercept. We would call this point on the x-axis an x-intercept later, but that's not for today. That's for a coming lesson. All right, going to find the coordinates of the points. Now this time we're going to give you a graph. Oops, sorry about that. Like I said, I'm still playing with the software. We're going to give you a graph and put a point on it, and we say find the coordinates. I want you to tell me where that point is. Now you can't tell on this graph because I haven't marked the axes with a scale at all. You don't know if that's a 5 or a 3 or a 2, but you'll see in the next slide that what we mean. Now, if I want to find the coordinates of points E, F, and G, now they already gave us the answers here, but if I look at point E, it's over here. What I would do is I'd start at the origin, and I'd have to see how far I have to go to get to that vertical line that point E is on. I have to go 1, 2, 3, 4 to the left. So the x-coordinate is negative 4. And then from there, oh, sorry. Man, this is going to be just like a deck of cards on you here. Sorry. So I go 4 to the left and they go down 2. So that point is negative 4, negative 2. 4 left makes the x-coordinate negative. Down 2 makes the y-coordinate negative. And we'd say that's in quadrant 3. F. Now I look at point F and I say, okay, I went over 1, 2 to the left, and I didn't move up or down. So the x-coordinate is negative 2, the y is 0. If I look at point G, I went 1, 2, 3, 4, 5, 6 to the right, and I didn't go up or down. I'm on that x-axis, so I have 6, 0. Now it is a rule that if your point is on one axis or the other, one of the coordinates must be 0. If you're on an axis, one of your coordinates is 0. If you're on the x-axis, the y is 0. If you're on the y-axis, the x will be 0. That's just something to keep in mind. It took me a long time as a student to realize how helpful that was to know. All right, so now we're going to look at whether we have a solution. An ordered pair is a solution of an equation. So remember, an ordered pair is when they give us an x and a y. So for an ordered pair, I have some x, y. So if I have an equation that says y equals 3x minus 5, and they say, is this a solution? It means this is the x, this first coordinate, and the second coordinate. So I have the point 1, 2. X is 1, y is 2. I replace the x with a 1 and the y is a 2 and see if I get a true statement. Let's look at a couple of examples. All right, so this is what I was just talking about. An ordered pair satisfies the equation or makes it true when you substitute the x and y and get a true statement. So, for this example, y equals 2x plus 6, the ordered pair, 1, 8, is a solution. And that's because x is 1, y is 8. If I put that in, I put in a 1 for x, and I'm trying to see if I get 8. So you do 2 times 1 is 2, plus 6 is 8. Yeah, 8 equals 8. That's true. That one works. 2, 3 would not be a solution because you're trying to see if this statement's 2. Y is 3, so you replace the y with a 3. The 2 is just this 2 from the equation here. So I multiply 2 times the 2, which is the x, plus 6. And I get 3 equals 2 times 2 is 4 plus 6 is 10. That is not true. So I am going to say this is not a solution. That's all you're doing when you're asked if you're given something like this. They say, is this a solution to this equation? You know the first one's an x and the second one's a y because that's always the way it goes. All right, so here's another example. We want to see if 3, 4 is a solution. 3 is x. It doesn't matter that. So this equation looks a little different. It's got 2x plus 3y. The y is not alone, but it's still a linear equation. It's linear because there's no exponents on either of the variables, and there are 2 variables. So 3 is x and 4 is y. So you put in that used to be an x and that used to be a y. Now you just have numbers. And you do 2 times 3 is 6 plus 3 times 4 is 12. Is that true? Yes, that's true. So that 3, 4, the ordered pair 3, 4, is a solution to the equation 2x plus 3y equals 18. All right, here's more of the same. 3 minus 3 times negative 2, is that equal to 9? Negative 3 times the negative 2 will give us a positive 6. Remember that from our sign number arithmetic. 9 equals 9. That's true. So this is a solution. So let's, I think that just switches that around, doesn't it? Let's just switch that around. Now x is negative 2 and y is 3. Well, this gives us different numbers to plug in. X is negative 2 now and y is 3. So I get negative 2 minus 9. You're going to negative 2 and you subtract 3 times 3. You can think of it that way. 3 times 3 is 9. Negative 2 minus 9, that's negative 11. So that one is not a solution. So the order that the numbers are in matter, and you have to be careful to replace the right number with the right letter. 3 needs to go to y. Negative 2 needs to go to x here. All right, so finding solutions of an equation in 2 variables. What this is going to talk about is we just found a solution or asked about a solution. It's helpful to be able to find more than one solution. Let's find 3 solutions. So you pick an x. Choose x and then calculate y. That's what you're going to do, but you're going to do it for 3 different x's. I am sorry, that is a lousy way to write the word calculate. Let me fix that. These will get better as we go on. I promise, I hope. Calculate. There we go. Calculate y. That's what we're going to see in the next slides. I'll have to explain them because it's all typed in already. So, you were asked to find 5 solutions to the equation y equals 3x plus 1. I'm sorry if you hear cats meowing. They're down here helping me. So if I need 3 solutions, let me make this. So for the first one, I actually choose this. Excuse me. I'm just going to start with x equals negative 2. So I replace the x with a negative 2, and I calculate y. So I don't know what this answer is here. I put the x is negative 2 in here, and then I do 3 times negative 2 is negative 6, plus 1 is negative 5, and that gives me y is negative 5, which says this point is a solution. Now I try another x value. I'm just going to work my way up. Negative 2 to negative 1. And you don't have to use negative numbers for lines, but it's just a good habit they're trying to get you into. So negative 1, this was my x. I replaced that, and now I calculate y. So I get negative 2. So this is what I did. I said I'm going to let x equal negative 1. I plug it into this equation and then calculate what y is, and that gives me an ordered pair that I know will be a solution. I repeat this when x is 0. I get y is 1, so I get the pair 0, 1. Now I can graph the line. Honestly, you only need 2 of these points to graph the line. But a lot of times your homework will ask you to do, for practice, to go through this calculation of 5. But really, I can just graph these two, or these two. It doesn't even matter which two. And then I could graph a third one if I wanted to check to make sure I actually had a line. But, I can graph any 2 points. I can graph this point and this point. And once I graph those and connect them, that's where my line is. And all these other points will end up on that same line. So here's another example with a different equation. So if I choose negative, so when you're asked to find 5 solutions, this is what you want to do. If they give you x's, you plug them in to find y, and then you make a point out of the x you started with. Didn't mean to do that. X you started with and the y. All right. Now, once you have a set of solutions, you can plot. A set of solutions is a set of points. You plot those points, and it gives you where the line is on the graph, and you can connect those lines because the line shows you a pattern that will continue, and it will be true for every point in between the points you plot. So you find several ordered pairs that are solutions. 2 is all you need. You find a third one to make sure the first 2 are right, because if the third one is not in a line with the first 2, then something is wrong. You plot them in the rectangular coordinate system, and you connect them with a curve. So I do this finding solutions. The equation here is y equals 2x. So 2 times negative 2 is 4. So I started with x is negative 2, so that's my x coordinate. Then I get negative 4. I can plot that point. The truth is, I could have plotted just 2 points. I could have plotted just this point and this point. And when I connected them, all the other points I calculated here over on the left would be on that line. So usually when you have to graph a line, you find 2 points, you connect them, then you find a third point and make sure it shows up on the line just to make sure you did everything right. So to graph this one, some of you are freaking out because it's a fraction. Don't. You can pick the x's, choose whatever x's you want, make them easy to graph. Because this fraction is 1/2, anytime you multiply this by an even number, remember multiplying by 1/2 is the same as dividing by 2. You'll be able, if you multiply 1/2 times x and x is even, you will get a nice integer. And I'm showing you all sorts of stuff you don't need here. Sorry. I'll figure out how to use this eventually, maybe by May. So that's what we do on the next slide here. Here's your y equals 1/2 x plus 2. So notice here we chose all even numbers. Negative 4, negative 2, 0, 2, and 4 are each even values for x. Negative 1/2 times a negative 4 is just going to give me a negative 2. Negative 2 plus 2 gives me 0. I started with x equals negative 4, and it gave me a y coordinate of 0. So that gives me, this graph is not correct. This is the graph of y equals 2x. So if I were to graph negative 4, 0, I would have graphed it 1, 2, 3, 4 right there. And then if I plug in negative 2, now it might be nice to skip ahead and do the 0. I'm going to graph the point 0, 2, 0, 1, 2. And now I'm going to draw a line between those. And that red line would be the equation of my line. Pretend it's straight. Okay, I'm doing the best I can here. But these are 5 solutions. If you're asked to find 5 solutions and you have a fraction for a slope, what we'll learn is slope if you're multiplying x by a fraction, pick numbers that are multiples of that fraction. If this had been a 3 on the bottom, I would have picked 3 and 6. Anything that that has a factor that is 3. So you do negative 6, negative 3, 0, 3, 6. If there's a 3 on the bottom. If there's a 2 on the bottom, just pick even numbers. If there's a 5 on the bottom, just pick multiples, 5s and 10, 0, 5, 10, negative 5, negative 10. That won't occur too much in here, but it's not hard to do. You can use your calculator even to calculate those things. It just is easier to graph. If it comes out a nice integer, it shows up right on one of these grid lines, nice and evenly. All right. The reason we do this is when we graph that entire line and fill in all those dots, it allows us to see all of the solutions. There are actually infinite solutions to a linear equation. You can pick an infinite number of x's and get an infinite number of y's, and you don't want to do that. Just draw the line, and once you draw the line, There's all your solutions. They're all in that line, and we usually put an arrow on either end to indicate that they go forward and backward in that same pattern in both directions. So this is plotting points and finding solutions to lines. I hope you understood this, and if you don't, you're going to email me and talk to me and do all those kinds of things. You should be able to get started pretty well in the 3.1 homework now. All right, take care.